Good morning and welcome to our first presentation of the day. The day 2 of the Kubernetes Community Days will begin with a presentation of Juan Velasquez and entitled Autoscale to Excel. And it's all yours.
Buenos días. Espero que aquí todos hablen español. ¿Todos hablan español o? Okay. So, if you weren't awake, I hope that catch your attention a bit. I know it's early in the morning. I hope you grabbed your coffee. So, my name is Juan. I work at Pure Storage as a software engineer. We have a booth here outside if you need some socks or a pen or a job. Please stop by. We can talk a bit more about the company. Oh, grab this. So I'm going to present Autoscale to Excel. If any of you thought that this was going to help you with your spreadsheets or that I was going to talk about VLOOKUP, please let me tell you that I'm going to be talking about Kubernetes, autoscaling, and specifically about one of our services, which is Perfworker. I will start giving you an introduction of the service, telling you what it does, how it does it, why is it important. Then I'll move on to the infrastructure. I will tell you how it was looking at the beginning when the company was in its early stages, and how it has grown now that the company has become like a leader in the storage industry. At the end, I will talk a bit about the challenges that we still have today with the service and where we are. So maybe, hopefully, you will guys give some ideas. We can stay in contact at the end. So, Perfworker. Perfworker is a service that generates performance report from customer logs. These logs allow us to keep track of devices that we have deployed around the world. Specifically, we use this performance report for customers that need support on their devices. We need to make sure that the devices are performing as expected. When the customer has a problem, the worst thing that we want is the customer to come to us saying, our device is not performing as it should be. What we want is to tell the customers in advance if they have some misconfiguration or if they are using something wrong, so we can fix it and avoid these issues. The way this service works is basically it's ingesting some logs that come from these devices. We process them, we parse them, and then we generate from some metrics the performance report. This is the initial infrastructure or the starting point. So as I said, when the company was still in the early stages, we had just a couple of hundreds of clients. We had some S3 buckets where the logs were coming in. We would just fire a notification with SNS. This notification would be stored in a queue in SQS. And then we had Perfworker, which was running on EC2 instances, just pulling messages from that SQS to consume the logs and then generate the reports. These are like some of the issues or the most important issues that we had with this approach. The main one is operational overhead. There had to be someone there doing the scaling. You know, if we deploy a new device, then there had to be someone there scaling up the EC2 instances or scaling down if we were over provisioning. Because of this, there was a delayed response to the demand of EC2 instances. So if we deployed a new device, it would be like it would increase the load, but it would come after some monitoring or some alert would trigger it. so it delayed because of this also. There was some resource inefficiency. We would be, as I said, over providing in most of the cases, which means that we will also spend a lot of money on the computing, yeah. Also, issues that we found were like, once it stops working, it doesn't, it just stops. Someone needs to go and start spin up a new instance. Well, in the best scenario, it would be just that it runs out of memory and we just need to provide either another instance or, yes, like scale it vertically. But the main problem here was when there was an issue with the code, with the actual code, then it would be a nightmare because we would have to go into the EC2 instance and check the logs, and you have a bunch of processes that are running different logs, so the observability was a nightmare. Also, when you have to do maintenance from time to time, as much as you want to avoid it, there are some times when you have to do it, the service then will stop working, the queue will grow rapidly, and yeah, we'll have issues there. Also, I mentioned the monitoring. Back then, the monitoring was basically just some alert from AWS, just sending an email. It was a bit, new. Inconsistent performance. We didn't really know how different type of logs would affect each process, as we sometimes have files, some logs that are bigger than others or have different contents than others. And also, this affects the service reliability. This is a service that needs the SLA, it's 99.9%. It has to be performing almost perfectly. So our customers are covered. So then, as you might have guessed, we did some EC2 autoscaling. Don't worry, I'm going to talk about Kubernetes. This is just autoscaling on the EC2. So this solves a couple of things, right? Now we don't spend as much time on the engineers don't spend as much time just going to the instance and scaling it manually. We have some, we save some time on the delayed response, or also efficiency and costs. We also, somehow the management, the complexity of the management is easier. This is all taken care of, but we create we find out about 3 new things. Lag indicators. So we're scaling based on resources. So basically, we're scaling once we are running on like 90% of memory or high CPU usage. So we are scaling once we are starving already. So also we have limited metric options. What I mean by this is we can scale only by CPU usage or by memory usage in most cases. And also this brings more, you have to set up some policies for the scaling, which is, not ideal. But at this point, the company, we have a team at the company for developer experience, and they came up with a tool to help everyone deploy their applications in an easier way. This tool uses Gradle, Artifactory to store the artifacts, and Spinnaker to deploy these artifacts on the Kubernetes cluster. So this was a big effort to containerize this application. And the current infrastructure just changed from EC2 instances to pods running on the Kubernetes cluster. So this is how it looks now. So some things that we really liked about this change were like definitely the deployment and went like much faster. We had the CI/CD pipeline set up somehow. It saved us like a lot of trouble there. Then we had already a Docker image, an artifact that would allow us to deploy this application basically anywhere. You could debug some stuff locally and so on. Portability, as I said, we have this Docker, so it's environment agnostic. You can basically deploy it anywhere. Also with Kubernetes, the guys implemented some monitoring and observability, which was basically Datadog and Graylog for the logs. We also set up some monitoring for, we finally could use some real monitoring. We created some metrics on the code to keep track of the performance of the service to make sure it's above 99.9. Also, we started measuring the time it takes for certain processes to generate the report. We could measure how long it takes on the creation of the report. We measure how much time it takes for the logs to be processed. So all this new information has helped us understand better what the application is doing and where the real issues are. Also, developer productivity was increased since we weren't wasting much time in the boring scaling up or scaling down, trying to understand how many instances you need for a new load and so on. And of course, this simplifies the DevOps. But we still had some issues. If you have a Kubernetes cluster, you also need people to understand what they are what they are getting into. So even if the team that is in charge of the Kubernetes cluster knows perfectly Kubernetes, you still need the teams who actually use the Kubernetes cluster to understand how to use it. So this is sort of a drawback in some cases. You need to learn about it. It takes some time. That's cool. But also we had another important factor, which was the lagging indicator or the reactive scaling. Basically, we were still stuck with a horizontal pod autoscaler, which basically means, like in most of the cases, you scale based on CPU or memory usage. And also you have someone to set up the Kubernetes cluster at the beginning, set the deployments, and so on. You still have the resource management issue because even though the autoscaling is it's set up there automatically, you still waste based on this reactive scaling. Waste some resources on this reactive scaling. So, what did we do? Well, at this point, the company decided to invest more on the service. We went through a major refactoring on the service level, the logic of the service, and what we did was we took this multi-process service and we made it so it would run one process, would just consume one log, and that way we would have like a more granular approach when trying to debug some issue or trying to understand why some log might be taking more time to be processed or might take more time to actually get into the processing. We still like, so what did we do? We started using KEDA. For those of you who don't know, I think everyone does, but it's Kubernetes event-driven autoscaler. KEDA allows you to use different scalers. Basically, you can use most of AWS and Azure services to scale your deployments. You can scale basically on pretty much all the native cloud native stuff out there. So what we did here with KEDA is we started scaling based on our SQS queue size. So This way, we would understand how many logs we were supposed to process, and before we start starving, we actually start the like scaling up. So since we have one pod or one job running one log, then this would allow us to consume them rapidly and decrease the resource waste as much as it can be reduced. So with this, like just as a recap, we went from some easy to manual scale, big chunk of code, processing many logs at the same time, to just specific pods running just one log at a time that allow us to debug and monitor the service much better. So I came here to learn more about what options are out there for us and what we can do better. I have already heard of, I don't know, a carpenter from for AWS on EKS, which would allow, like right now we're using Autoscaler groups for nodes, which I didn't know. It takes a lot of time, and the carpenter will just spin up a new node just as it goes. So if you have any ideas or any suggestions, please, this is my LinkedIn. Please contact me, or if you want to talk about something else or the company, don't hesitate to contact me. And that's it. I'm ready for your questions.